Good afternoon, everyone. Thanks for coming here. It's a great pleasure to see so many of you come here after a dinner or lunch. It's never easy to step in a session after lunch, so hopefully I will keep you awake a little bit. I'll start the talk with a story, and a story of this man, Thomas Edison. Right? So Thomas Edison is quite known for having invented somehow a light bulb, right? But in fact, he didn't really invent the light bulb. If you look at the history, there were 23 light bulbs invented before Thomas Edison invented his, right? But he still did a lot of work. And in fact, what he did is a series of experiments. In fact, 6,000 of experiments to figure out which of the filament he could use in his light bulb. And it was carbonized bamboo, right? But it actually is not that gave him the title of inventor of the light bulb. What really happened is, or the strike of genius really was a few years later. It was, in fact, in a street called Pearl Street. And what he did is assembled a bunch of ideas from other people, a distribution cable, a connection, a device to connect the light bulb to electricity, a meter to put inside houses to figure out how much people were consuming electricity. And he did something quite spectacular. He totally lighted the street, first time in history. So in fact, the light bulb itself was rather a curiosity piece, right? But the fact that he assembled everything was the magic. So I think it's easy to say that in fact, the light bulb is a product of invention put together to create the wow. Right? And if you think about now, how would you reinvent the light bulb today with all what you have at hand? Should we do a little experiment and see how I thought about reinventing the light bulb? If you could take your phone and go on this URL, there's also this QR code if you want to use it. And you should arrive on a page with a light bulb. Something similar to, to that. Right? The only difference is you don't have the slider, if I've done everything right. Because in the real world, I'm Thomas Edison, and I can control everything. Right? And I'm a control freak, so I want to be able to control all your devices at once. Right? So if I move, for example, how many of you see the device updating in real time? Right? All right, so this is quite interesting, right? Because now we're going over the internet. I'm actually using a slider to update all the pages you have. Interesting ideas have done that. But that's not all, actually. Here I have an Alexa simulator. And I can do something interesting with Alexa. She's now listening, because I was telling her name and saying something stupid. So, Alexa, ask Lightbulb to set the brightness to 50%.
The light bulb brightness has been set to 50.
Have you seen the device, right, setting up? You can say, Alexa, ask light bulb to flash fast. So there's a bunch of things that you could do, really. And in fact, I've done this experiment with almost 500 or 600 people, and pretty much everything was synchronized. Now, you probably wonder how we've done that, right? Or how has this been done? In fact, this is as simple as that in terms of architecture. And I'll discuss the architecture later, but this is just to give you a little preview on kind of similarity of Edison's thinking, that nothing was invented, it's just pieces put together to create something cool, right? And this is really what cloud is, right? And this is really what is interesting here, because imagine if you would have to build this yourself without cloud, if you would have to build a system that can handle as many connections as you can, from 1 to millions, have this bidirectional communication, being able to do this securely, because in fact, all your devices had authentication to connect to the service. It would take quite some time. In fact, I've worked with IoT device for almost 15 years, and trust me, 15 years ago, we were trying to port a TCP stack on a low operating system, and that took us roughly 6 months to refactor the entire thing. And then another 4 months to refactor or to port an XMPP protocol on top of that. Now, in a couple of hours, we can do things like this, right? And in fact, there was no genius involved, right? Like Edison, it's just a bunch of experiment and then putting things together. It's really what it is. And leveraging the cloud and then doing prototyping and experiment and just trying things out. And this is how easy it is to build application. It's not what it used to be 10 years ago, where we had to make a 6 months or 9 months plan and figuring out how we're going to get infrastructure, how we're going to scale that, and all these kind of things. So why are we talking about IoT? Because at the end of the day, this presentation is about IoT. Well, for a few reasons, right? Data is definitely a competitive advantage, right? If you're a customer and you have data about your operation, about your company, about your customers, and if you can act fast on that data, then there's a massive competitive advantage that you have over your competitors. You can understand in real time the sales. You can understand in real time maybe how a fleet of trucks are being dispatched. You can do predictive maintenance, avoid massive crash. Right? You can detect small variation of vibration and act upon it. This is why IoT has been so popular, right? And in fact, in the last 2 years, IoT has totally boomed. And this is, in fact, really correlation with the cloud, because we did have IoT before, but it was very difficult to set up the environment, to scale the environment, to act on the data. Now we have all the service that we can just stitch together, and all of a sudden we have very useful application which we can put in the market and start iterating with our customers. And in 2015, we launched a service on AWS called IoT. And this is because our customers were in pain of doing exactly this, building an infrastructure to support millions of devices, securing them, doing actions and rules on those messages that were passed at scale. It's not trivial. And if you're from this country, you probably, or the Nordics, you probably know Telenor, right? Telenor is a Norwegian company that has operation in Stockholm, and what they do is IoT. They use IoT to provide services for the like of Scania, or Volvo, or other companies like Hitachi. So they have a platform which is based on AWS, IoT, and they provide their services to other customers. And they could do this really fast. In fact, they're saying that in just 4.5 months, they were from ID to deployment, which is quite spectacular if you think about it. Other companies, if probably you've heard of, is iRobot. How many of you have autonomous cleaning machines at home? I don't. So, you're a happy customer of AWS IoT. In fact, when the robot goes around your house, it scans the environment, all the telemetry is sent in real time on AWS, and analytics comes, and then they do all the 3D mapping of your home and all this kind of stuff, right? Philips is doing similar things for their health suite. They collect telemetry from patients, aggregate all that data with images and videos and scans and all these kind of things, process all that information to give back to the customers some advice about their health. BMW Series 7, if you have that car, everything that is being updated in real time on the maps, on the GPS, is going through AWS IoT. There's tons of applications where you can use and in fact, there's many, many more, right? From car share or Ratio, which has IoT devices on their watering system to monitor in real time the weather and the soil condition and adapt the watering of their plants. So there's tons of applications that people are now using very fast, adding this as an offering for their customers. I want to talk a couple of things before moving to some more demos in the key features so that we all can understand how things work. And there are 6, like those are the first 3. A registry is quite simple in its nature. It's very difficult to do at scale, but it can keep tracks of all the devices that you have in your environment. From 1 to million, it will keep an ID which certificates are deployed. So if you want to kind of manage groups of devices at scale, you will use a registry. And this is a feature that is available right out of get-go into the service. The second one is very important, and is a language that is used across the entire IoT spectrum, is the shadow. And the shadow is quite simple. It seems complicated like this, but it's quite simple. It's a virtual representation of a device in the cloud. And there's few reasons why we do this. When we build applications for IoT devices, we do not target the device directly. We use a shadow, which is in the cloud, so that if your device goes offline or experience some intermittent problems, we can still have a workable application, right? So we do all our application against APIs on the shadows, and then if the device is online, the shadow replicates the data directly to the devices. If they are not online, they will have a conflict resolution happening as soon as the devices come online. The third thing, which is very important, is rule in action. And this is quite simple. What do we take from that message, IoT message, and what do we do with it? And the rule is an SQL statement. So the same way that you would query your database, you say select from the stream, and then the fields that you want to extract from that particular message. And very often, messages are JSON objects, and I'll show you after that. Another thing, another set of features that are important is the protocols. And there are currently a set of protocols that are supported. And now you might realize how the first demo was done. You can do MQTT over WebSockets, right? So when we do bidirectional communication with devices, it was actually a WebSocket communication. And you can do MQTT or HTTP as well. So it's a set of different things. You support, or we can support PubSub, right? So basically, all the device by default will subscribe to their shadows, and anything that happens on the shadow will be broadcasted to the devices, right? For the very reason that we want to have the state propagated in real time. And of course, secure by DevOps. So there's a bidirectional security protocol X509. So when you set up a device, you need to put the certificate inside the device, and that's pretty much it. And in the big picture, it looks something like this. The only thing that you need to do is really bring the SDK on your devices so that you can start communicating with the platform and use all the features that was mentioned before. And then, of course, you need to build an application. And you see on the right, on the lower part right, my application talks directly with the device shadow. Right? So you can do, all the platform can do aggregate calculation, and then you do application deployment and development on the shadow. So this is quite straightforward. And with this, you can do quite substantial amount of things. And the typical use case, which I'm not going to demo today, but is really something like this. And if you want the entire code and things on my GitHub account, how you could set up Raspberry Pi to use that pipeline. But this is maybe 80% of the use cases that we see, is that devices, sensor sends their data to the IoT service, and then there's a couple of rules. One is often a rule that sends the data in real time to Elasticsearch, for example, to do timeline analysis, real-time analysis of time time series, so you can detect patterns and changes in patterns very, very nicely. It supports Lucent type of queries, so it's quite interesting. And the second one is really start storing the data into S3 using Firehose, and then being able to query the data that is stored into an object storage, so S3 in that case, with, for example, analytic tools like Amazon Athena, which allows you to do SQL queries on data that is sitting into S3 without having to set up any database or anything like this. And then, of course, you can use the tools you want to do visualization. Right? So this is very, very classic architecture for things like this. But that's not all. Right? In fact, there's many other architectures. The one that I presented before is one of them. And there's another one that I want to play and do with you and show you how far we can even push the system. So if you could also go on that URL so that you participate in the talk as well. I'm sorry I make you work. After lunch is terrible. All right. You got it? You should have a screen that has squares, right? So let me go there. So now you can start clicking on all those in real time, and you'll see the cube will update and see the number of votes. So now we can see the winning color is green, but let's say in real time, let's all go on clicking blue, for example, so that we can see in real time what's happening. And you see now in real time, the winning is blue right away. And this is very interesting, right? Because now you're all modifying the platform in real time, right? There's actually, let's see, about 134 clicks per second happening. So there's either there are a lot more people that I can see, or there's one with really fast finger. Who is the fast finger? But this is the kind of things that we can do. And this is just a demo to show you how fast you can go from sensor, because your phones are sensor, to understanding what happens in aggregation, calculation, and behavior. Because in fact, this is just for fun, right? But it could be actionable, right? It could be, oh, wow, my fleet of trucks and cars are all around, these are doing this, all these kind of things. Right? So it's quite interesting. Let's all go on the red just to see that I was not, come on, red. Yeah, you guys have clicked on blue a lot. Cool. You're the one clicking that fast. I can see it in your eyes. Yeah. All right. Anyway, this is the kind of architecture that is used for this demo. And this is, again, super straightforward. Only 3 services used, or maybe 4. But the principle is when you go on the URL, it loads a HTML page, which loads JavaScript, which then makes calculation on which color you click and send that information in JSON in real time to an IoT device, to the IoT service. And in fact, my dashboard is connecting to IoT service and subscribe to the channel in which every one of you was sending, right? So my dashboard listens to the topic and then takes that and pushes this into DynamoDB. And then that's it. And all the calculations are done in real time on the front end. Right? So there's tons of things you can do like this. Really nothing spectacular. If I don't use this, I don't pay for it. Right? There's no cost. The only cost here is the HTML page in the S3 bucket, and then the number of points that I will store into DynamoDB. And then I can auto-scale down the DynamoDB table when it's not used, right? And then purge it, because I pretty much don't need the information after the demo. Here, there's a service called Cognito. Cognito allows you to get a token, right? A token is an identity token. It supports authentication and authorized and unauthorized. So you're kind of unauthorized as guests, and you're allowed to send data to this IoT topic, this particular IoT topic channel. So this is fairly simple to build. I want to show you a little bit in real time what happens. Because if I go and inspect there, you see in the console, you will see that I'm listening there. Right, this one. All right, I lost it. I can't get the message in big, so let me reload that. Right. Oh, there. This is the topic in which I subscribe. And what you can do, interestingly enough, this is the console for IoT on AWS. You can test with an Mqtt client here. So for example, if I put this, you can see in real time all the messages that are being sent by you. There really is a clicker here that goes really, really fast. So you see, it's quite simple. It's just someone is really going crazy there. Stop clicking. This is my JSON. Thank you. This is my JSON object. Who is that guy? All right. And you see there's a Cognito ID here, and it's individual for everyone. Right? So then I can also calculate the number of real-time users, and this is the data that you saw in real time on here. This one. All right. There's still like 40 people in real. You guys. Anyway, let's move on. Now the thing is, some data, or some of it, will never, ever reach the cloud. Right? And there's few reasons for that. Whether you are working in medical field or industrial equipment field, for example, under mines or things like this, or in extreme environments, say in the North Pole or in a cave or something, there's tons of places where we do experiment with sensors, and there's not necessarily our 4Gs, right? Or sometimes there's not even satellite connection. So, and also there's something called the law of physics, right, the speed of light. So for example, if you are an autonomous driving system, if you are a car, and you make all your decisions in the cloud, you might have some issues. Because a sensor might detect a car coming face to you, and if the latency is a bit too long, say 300 or 400 milliseconds, it might not work very well. So we don't want to make all the time decisions in the cloud, right? It's quite obvious. We need to manage situations where decisions have to be done locally. The laws of economic as well. In fact, sometimes it's much cheaper to reason locally. We don't necessarily need all the data to be processed in the cloud. Data sent in the cloud does cost money. Right? It's bandwidth utilization. If you sometimes can react locally, it's just cheaper. And at scale, if you have millions of devices, sometimes it makes a lot of sense. And of course, the law of land, right? The privacy and sometimes regulation do not allow you to upload data into the cloud. So customers have had those problems. So what we did is, a year ago, we launched something in the suite of IoT called Greengrass. And Greengrass takes all those situations and allow you to run your compute and your decision locally on your device. And there's two things to realize with Greengrass is there's a Greengrass core, which is in fact your gateway and makes local decision, local routing, and then the devices. And devices can subscribe to each other locally and make local decisions. Right? So for example, if you have a speed detector or temperature sensor that detects change in temperatures, you don't necessarily have to go to the cloud to shut down the oven. Right? You can act through the Greengrass core directly and make local decisions. Right? So that means the Greengrass core has compute. Right? And what we do is, with compute is, you use Lambda in the cloud, and then you can deploy them on your Greengrass core. Right? So you don't lose the programming models that you have when you do application in the cloud. You just then deploy them to your devices. Yes?
What kind of platforms are we talking about when it comes to Greengrass core?
Right. So I don't remember exactly the numbers. I can throw them to you, but it's rather small. In fact, you can run a Greengrass core on a Raspberry Pi 1.0. So it's quite fine. I don't remember exactly the numbers. I'll throw them at you after that. And in fact, there's already customers using that. And this Rio Tinto, which has equipped all its fleet of trucks with Greengrass core, because those trucks go in mines in very hazardous terrains, and they have tons of sensors around the truck, and they need to make fast decisions, right? And they use Lambda to make those decisions, but they don't use Lambda in the cloud. They use Lambda that is on the Greengrass device, right? But that's not all, right? Now we can think, okay, we are deploying compute. We have Lambda functions in the cloud. Now it makes everyone think, what can we do now? And in fact, I want to show you a couple of things. If I have sound.
Moments after receiving the order, an electrically powered Amazon drone makes its way.
The sound doesn't really matter, to be honest.
Rises into the sky with the customer's package on board.
So these
drones are autonomous.
These are our drones.
From takeoff to
series.
landing and return, they operate completely on their own.
And we use drones to deliver packets the last mile. So it's an experiment still, but we started to experiment with that. And in fact, those drones are using the same machine learning algorithm or AI that are running in autonomous driving system cars.
The customer receives their
and what they
package.
do in real
For this
time, they look at
initial
all
trial, customers
what
can
is
choose
happening
from the
in
latest tech gadgets to their
in
dogs.
the environment. Oh, what? They look at all what is happening in the environment and make local decisions about obstacles to avoid and things like this. Right? So exactly the same AI that runs on autonomous driving system. And recently, you probably heard about it. It's a new concept that we now open to public in Seattle called Amazon Go. And Amazon Go does something quite interesting is we cover the entire roof of a grocery store with sensors, cameras, and then we follow people in real time, and you can just go in the store, take things, put it in your bag, and then just leave the store without having to wait for a cashier, without anything. So it's totally AI-powered and sensor-powered. So and decisions are also made quite locally, in fact. We all have tried to cheat the system, I think. And it's very difficult. I especially tried to cheat the system with chocolate bars, very thin, to put them on top of each other. I've never managed. There are people that have put stuff on YouTube that managed to cheat the system, but they have actually put the code on top of themselves so the cameras cannot see. So if you go in Seattle and you want to steal stuff, that's the way to go. Just don't tell Jeff, I told you. And this is the next version of where we are going. And if you follow a little bit what happens in re:Invent, re:Invent is our largest customer conference that happened in Las Vegas a few months ago. We launched something called Greengrass ML. And this is Greengrass, so it's the same principle I've explained, but now you can deploy machine learning models there, right? And what you do is you build your machine learning models in the cloud because machine learning models need a lot of compute. You wouldn't be able to compute a model on your Raspberry Pi. It might just take a couple of months. Right? So what you do, you start all your instances in the cloud, few hours, train your model, store your model in S3 or make an endpoint, and then deploy those models on your devices. And this is really happening today. In fact, I have a little device here. It's called a Deep Lens. And this a device that we showcase at re:Invent as well that we'll make public. So if you are into Raspberry Pis and stuff to hack around, this is something you should look for. And this is just a device that runs Greengrass ML. Right? So I can build my models in the cloud and then deploy them to the device. And I want to show you a couple of demos. I'm taking a lot of risk here because this is a prototype device that I already burned a few times in my hands. But I thought, well, I already had a few demos working, so why not? So let me put that here, and I'll show you how we do that. And when you build into the cloud, there's a tool, something called SageMaker. And I want to talk quickly about SageMaker because it's really the core of the idea. SageMaker is a new service that was launched as well, and you can just by a click of button start a SageMaker instance, which will have embedded all the libraries, the machine learning frameworks that you need to do development. But it comes with a set of what we call notebooks. So I'm going to show you when you start your Jupyter, you will be landing on a page like this. I'll just show you because you see I have my instance here deployed. It takes a couple of minutes to deploy your instance, and then you can start just opening like this. You don't have to SSH in the machine or anything. And then you have access here, I'll show you in Bing, of sample notebooks. All right? And this, you need to listen because this is something super interesting and that most people do not tell. There are complete guides on how to build functionality, the same functionality, same machine learning algorithm, same AI algorithm that Fortune 500 companies are using. All right. So for example, we've put all the Amazon algorithm that we are using heavily. For example, the factorization machine. There's the notebook here, and then you can start following line by line how we do things. What is involved, learn about the topic, modify the code here. You can put your bucket and all this kind of stuff. This is very, very interesting. And I use that a lot to learn about machine learning, right? Because there's so much going on. Everyone is talking about machine learning, but not everyone is telling you how to use this. So what we did is we put the most important algorithm that are used in Amazon. Another thing is you also have access to other notebooks, right? So for example, if you want to start doing cancer prediction, you can look at, for example, the Jupyter notebook that tells you how people do it. Right? This is now available to you. Right? You can actually, I'll set my kernel, it doesn't really matter. You can go here and follow the notebook line by line to learn how things are done. And you can modify, you can execute the cell in real time, see what happens. And of course, I've done something that I want to demo you. And if you're into hot dogs, I created a notebook with a friend that will help you detect hot dogs or not. And this is a reference to a show. Yeah. How many of you have seen the show? Yeah, cool. So it's a show that is in the US, Silicon Valley, and the guy is trying to set up a startup, and for that, he just builds an app which detects hot dogs and not hot dogs. So here, the notebook does something very similar, loads the pre-trained model. And this is the second thing that I want to come across and that you take home. If you want to use deep learning or AI or machine learning, you don't have to create the model from scratch. Right? And this is something no one really talks about. There are tons of models, pre-trained models, available online. It's called model zoos. Right? And the technique of transferring a model and reuse it is called transfer learning. And this is used all over the place. Like Expedia, for example, set up the entire image recognition system doing transfer learning. They use a pre-trained model on a very large image data set, and then they tune parameters for their use case. And this is the way to go. Very, very few people deploy or create their own model from scratch because it's very, very complicated. It involves a lot of mathematics, a lot of understanding of the ins and outs of neural network. And this is not for everyone, right? But if you are simply curious, then you can already start building things. So this is the notebook for doing hot dog classification. And here I'm using a model that is available from SqueezeNet, and that is also trained on ImageNet, which is a very public image library that is used very often to test whether your algorithm is good. It's a reference data set. And here, so I'm loading the pre-trained model, and then you can see I start do a couple of things. This is the parameters training, but then I have a classify hot dog function that basically takes an image and invoke the classification, and what it does is, in that case, I can load a picture and see if the pre-trained model works. And in that case, you see the pre-trained model so that it was 60% chance that this was not hot dog. Even though it's an image classification model, it doesn't mean that it's not good for use cases, right? What you can do is simply modify parameters so that you can teach it to recognize hot dogs. And there's a bunch of ways to do that. I'm not going to go too much into details, but for example, you see here, this is my second picture, which quite resembles a hot dog, and this algorithm thought actually it was a hot dog, but it's just a dog. But then what we do is we load parameters that are tuned for the use case we want, and then our algorithms start to recognize hot dog. And you see the probability for a hot dog is now 62%. And then this becomes a dog. So it's quite easy, right? Of course, there's some math. Of course, there's a couple of things to understand. But this is really a takeaway that I would love everyone to know, that you don't have to train your models from scratch. Use pre-trained model, go in model zoos, and start experimenting with that. Here, what I'm doing then, I'm loading the models into an S3 bucket. And I do this because then I can go into deep lens. Now I'll show you deep lens. This is my console for deep lens. What I can do is I can build models, for example, a model here that loads my model from S3, and then use a Lambda function called deep lens hot dog, no hot dog, to do the prediction. So it runs onto a Gridgrass core. I'm deploying a Lambda function there, load the model from S3, and all of a sudden I can start doing prediction. And you might think, oh, but that's crazy because your models are probably very big. In fact, no. Models are not big. Even if you have a 500-layer convolutional neural networks, it's in the hundreds or 200 megabytes or 500 megabytes, something like this, compared to the data that you need to train the system is ridiculously small, right? But to create the model, there you need an enormous amount of data, an enormous amount of computation. That's why we do this in the cloud and then moved it to the edge, right? So then when I'm done here, I can create a project, and you see I have a hot dog recognition project, and then I can just deploy to the device. And I've already deployed to the device, but you could do something like this. I'm not doing it because last time when I did it, it crashed. So I'm just pushing the demo guns, not pushing too far the demo guns, but I want to show you now once it's deployed what happens, because then my deep lens now is in real time telling if there are hot dogs in the audience, right? Then you see there's quite a high probability that there are no hot dogs, actually currently 99%. Well done. Do you want to bring the laptop? Let's try to see. We'll try to put the image of a hot dog. I do not guarantee anything. My startup didn't get funding and things like this, but this is just for the fun of it. So let's try to see if it can start. Come on. Come on. Yeah. I probably won't get any funding this year. I guess I'll let me go. I had it actually really bad. Sorry. Oh. Oh, there we go. It thought for half a second that it was a hot dog. I might get a couple million. There. We have a hot dog. Woo! That's the first time the demo works. So you're so lucky. I'll stop here. Well, you just get the idea, right? That I can now train all my stuff in the cloud and really a couple of click, load the model from S3, use my Lambda function, and if you want to see the Lambda function that does that is here. It's basically loading the Greengrass SDKs and kind of thing. And what it does is extract frames, the iframes for the video feeds, and then do the last frame, and then do the predict function, right? So do inference, right? And that's pretty much it. And then I take the results, I print this, no hot dog, and here, oh my God, a hot dog. This is the message that is sent to the IoT topic here, right? My IoT topic. And that's pretty much it. So you see, I created a device at the edge that runs hot dog, no hot dog. And to be honest, the first time it works, the demo like this, usually it always crashes. So there must be something good here. On that note, I mean, I don't have much to say. So I'm happy to take some questions. There's 10 minutes left. Either you can take a longer break or we can go some questions. The demo was done, and I'm just thank you for that, really. No question? Good. That's all right. Yeah, you have a question, sir.
How about managing different versions of the different IoT devices?
Right. So the question was, how do we manage versions of the software that we... Right. So what you do is really do over-the-air updates, right? In a way, and the infrastructure should not be your stopper for that. So basically you can use, and how customers do this is they have a listener that subscribes to a topic, and then on that topic you can tell that there's a new version of your device, of your software, and then the device will download this, either from a storage, local storage, S3, or some customers, if it's very short, have streamed that as well, but I don't necessarily recommend these kind of things. But you can tell all your device all of a sudden to do an update by using the pub/sub methods. Right? So, of course, you don't want to do that. This is a rough answer. You don't want to do this if you have millions of devices. You want to do a rollout. So your software, local software, should kind of manage that in a way, right? And to do this, you can use groups, right? So I didn't really talk about this, but when you have your Greengrass devices and cores, you can define groups of devices. So for example, my sensors that are in Finland, in Sweden, in Norway, and then do updates for each of the groups, one after another. These are strategies that customers are using. But we do not currently on the platform support. You cannot just bring your sensor software on the platform and say, update on my device. We don't do this, because every customer has different type of software. Yeah?
How are you built on the computations running on the Greengrass?
So can you repeat, sorry?
The billing on computations running on the Greengrass.
The billing? Well, this is your device, so there's no computation happening that you're built for. The only thing you're built for is a Lambda function that will be in the cloud, and then when you deploy on your Greengrass core, then it's there, right? Yeah. You pay per Greengrass core, right? So that you deploy in your environment. And then what you do locally, there's no connection to the cloud, so you can do pretty much what you want. All right, another question?
Are you thinking of using anything else than Mqtt for Amazon IoT, or is it not for anything?
So we in fact just added a support for industrial protocol, which I don't remember the name, I'm sorry. I can look it up, that many industrials wanted to support. But what we noticed, Mqtt is extremely good in very bad network conditions, right? In fact, you can see here, even with this Wi-Fi, with that many people, and it worked pretty well. And this is also the feedback that we get from customers. And Mqtt is a standard, so you can, in fact, develop your own client, Mqtt client, to subscribe to topics as well. So it's kind of widely used, so that's why we went for that. But as I say, you can support MQTT over WebSockets as well, and things like this. So this is an HTTP endpoint as well. So if you don't want interaction, you can have your device simply doing a REST call put on an endpoint, HTTP point. Good. All right. Thank you very much.